Hi, and welcome to section 3.4, Beyond cpctc. Today we're going to be identifying medians and altitudes in a triangle, understanding auxiliary lines, and writing proofs involving steps beyond cpctc. Tomorrow in class we're going to be working on problems 2 through 12, the evens, and number 11. The first definition we come across is the definition of a median. A median is a line segment drawn from any vertex of a triangle to the midpoint of an opposite side. So let's see what this would look like. Let's say that we have segment AB is the median. If AB is going to be the median to segment CD, then it would create two congruent segments. So we can summarize median as dividing a segment into two congruent segments. Now, how does this differ from a bisector? A median has to come from a vertex of a triangle. That has to be its starting point, whereas a bisector can come from any point. Okay, so let's check real quick for understanding. I want you to name the medians that are shown. Press pause, look at the picture, and let's see if you can name the medians. Okay, we have two medians in these pictures. One median is going to be segment IS. The second segment that's a median is going to be segment LN. Those are going to be the two medians because on both we have congruency formed. Our next vocab word is an altitude. An altitude is a line segment drawn from any vertex of a triangle to the opposite side and perpendicular to that side. So in this triangle, if segment AB is the altitude to CD, what would happen is angle ABD and angle ABC are going to be right angles. Altitudes are kind of like perpendicular lines. Again, perpendicular lines can come in anywhere. I can have a perpendicular line drop here. As long as we knew they were perpendicular, we would know right angles were formed. Altitudes are different in the fact that it has to come from a vertex and drop to a side opposite, forming that right angle. It's a special kind of perpendicular line. Next, we're going to talk about auxiliary lines. Auxiliary lines is one of the most underappreciated properties in honors geometry. Auxiliary lines are adding lines, rays, or segments that do not appear in the original figure to the diagram. In other words, if we're given the information that BD is congruent to CD and AB is congruent to AC, we want to prove these angles down here are congruent. Well, we don't have any triangles to go off of, so an auxiliary line would need to be drawn. Auxiliary lines connect any 2 points. So what we can say inside our 2-column proof is we can say draw AD. And the reason why we can say that is we can say AUX for auxiliary. It's a line that exists by connecting 2 points but does not appear in the original. Alright, the moment we've all been waiting for. Let's start trying some proofs. Alright, so here's our first one for going beyond cpctc. We're given AC is congruent to BC and AD is congruent to BD. We want to prove that ray CD bisects angle ACB. Let's think about that for a second. If that's what we want to try and prove, what has to be known in order to say we have a bisector? Well, we have to know that we have two congruent angles. So that's kind of the goal of this whole process. So here we go. Let's go ahead and let's start with our 2 columns. And let's enter in those givens. So we're given that AC is congruent to BC. That's going to be given. I said congruency, I mark congruency. I have that AD is congruent to BD. I said congruency, I mark congruency, and now I'm observant. I see reflexive. CD is congruent to CD. The reason is reflexive. I said congruency, I mark congruency. And I look at my two triangles, and I see that I have enough information for triangle congruency. Triangle ADC is congruent to triangle BDC by the side-side-side postulate. Now, we have three things that have not been stated and can be stated from cpctc. Angle A and angle B are corresponding. Angle D and angle D are corresponding. And angle C and angle C are corresponding. Now, if we want to eventually prove that angle ACB was being bisected, the cpctc that we're going to want to write is angle ACD is congruent to angle BCD by cpctc. Again, I stated congruency. Let's draw it out. Now, if I have two congruent angles created, what that meant is the line going through them must be the bisector. So we're getting to our conclusion. Ray CD bisects angle ACB. The reason, if a ray divides an angle into two congruent angles, it bisects. Alright, moving on. Our next proof. We have CD and BE are altitudes of triangle ABC. We also have that AD is congruent to AE, and we're trying to prove that DB is congruent to EC. Let's go ahead and let's get started. We've got our statements and our reasons. Start off with those givens. CD and BE are altitudes of triangle ABC. That's given. And AD is congruent to AE. Let's draw that in. AD and AE. Now, if we know we have altitudes, we know that right angles are going to end up forming here and here because we have two altitudes. So I have to think about what triangles I actually have here. I'm going to go over them in color so we can see what we got. Make it a little bit darker for us. The two triangles we're going to have is triangle ADC, which has one piece of congruency right here. And the other triangle that we're actually going to have is going to be triangle AEB, which had its piece of congruency right here. Now, our step 2 is going to be to look for reflexive size and reflexive angles. And we should notice here with those red and orange colors that we have overlapping rays. Angle DAC is going to be congruent to angle EAB by the reflexive property, which is going to be this angle up here. It's the same on the orange as it is the red. Now, let's use those keywords, altitude. Now, we got two different altitudes. So here's what I'm going to have. Two different sets of right angles. I'm going to have angle ADC is a right angle. Definition of an altitude. And I'm also going to have, draw that in, angle AEB is a right angle. Definition of an altitude. Now, they're both right angles. They both have the same tick marks. Let's say they're congruent to each other. Angle ADC is congruent to angle AEB. All right angles congruent. Now, looking at that picture, on the orange triangle, I have three pieces of congruency: the reflexive angle, our side, and our right angle. On our red triangle, three pieces of congruency: our reflexive angle, our side, and our right angle. I can say triangle ADC is congruent to triangle AEB. The reason? Angle, side angle. So why is DB going to be congruent to EC? Well, those aren't full sides of my triangles. What I do have as far as full sides go for cpctc is to say AC is going to be congruent to AB. So let's go ahead and state that. AC is congruent to AB, cpctc. Now, here's what we know. We know those big pieces are congruent, and we know these little pieces are congruent. There's an overlap that's going to happen. If I take out this overlap from the big segments, I'm going to be left with DB is congruent to EC by subtraction. That was a tough one, not gonna lie. Not undoable, but really, really tough. So if you got that with me and can follow, great job. If we got questions about that, we're definitely gonna go through another one like that tomorrow. Alright, here's another one. Let's go ahead, let's start off with those statements and reasons. We're given G is the midpoint of FH, and EF is congruent to EH. I said congruency. Let's draw a congruency. And now I'm going to start running into a problem. I don't even got two triangles here, but I see that I have a point E and a point G. Let's go ahead and let's draw EG to create two triangles. And the reason why I can do that is auxiliary. Auxiliary allows me to connect any 2 points. Now, let's look at our picture. And what do I notice? EG is congruent to EG, reflexive. So I was observant. Next, I'm going to use my keyword midpoint. If G is going to be the midpoint, I know that HG is congruent to GF, definition of the midpoint. Let's draw them tick marks in. And now I have enough to say triangle congruency. I can go ahead and say that triangle HGE is congruent to triangle FGE. The reason is side, side, side. Now, somehow I have to work in angle 1 and angle 2, which aren't even parts of our triangles. What I do notice about 1 and 2 is that they're next to angles in our triangles. They're supplementary. So for my cpctc, I'm going to say that angle EHG is congruent to angle EFG. cpctc. These two angles here are congruent. Now, let's start with our supplementaries. Angle 1 is supplementary to angle EHG for my reason. If two angles form a straight angle, they are supplementary. And also, angle 2 is supplementary to angle EFG. The same reason. So it's the same as 1, 2, 3, 4, 5, 6, 7, 8. We're on our 9th stop. Now, get out my highlighter and let's look for things that are repeated. EHG is repeated. EFG is repeated. So what's going to be left then is what we're trying to prove. Angle 1 is congruent to angle 2. Supplements of congruent angles are congruent. And that's it. Alright, here's our last one, and this is one for you to try. Let's see what you can do. Let's press pause. Try and work through this the best we can. If you need a little help, unpause it, and let's see what you can do. Alright, so I got my givens and I got my markings. And wow, is that a picture to say the least. Alright, I don't got anything to observe except for something that's reflexive, and that's not going to be really helpful to me. That SZ. I don't got much about those bigger triangles, so I'm kind of stuck. Here's what I'm looking at for right now, though. I got two pieces of information about this triangle right here. Let's see if I can get that right in for me. About this triangle right here, and this triangle right here. I got 2 out of 3 pieces, so that's a good start. And what I notice, I also have pieces next door right here. So here we go. Let's start using our supplementaries. Let's say that we have angle SVZ is supplementary to angle TVZ. Reason? If 2 angles form a straight angle, they are supplementary. So that's these 2 pairs right here. Let's do our other side. Angle SXZ is supplementary to angle YXZ. Same reason. So we got the same as number 4. Now, get out my highlighter, look for our repeats. We got repeats for angle SVZ and repeats for angle SXZ. So the ones that are left over, angle TVZ is congruent to angle YXZ. The reason is they're supplements of congruent angles are congruent. Now I'm going to go ahead and draw that tick mark in. Draw a little tick with a line, and a little tick with a line. Now looking at those red triangles, I got 3 pieces of congruency for angle, side angle. Let's go ahead and say that. Triangle TVZ is congruent to triangle YXZ. Angle, side angle. Now, we're trying to prove that we have a median here. We know medians, the effect of a median is congruent segments. I can say that TZ is congruent to ZY by cpctc. Now, if I know that I have that, that makes Z the midpoint. And if a segment is starting at a vertex and connecting to a midpoint, we know we're going to have a median. So for our very next step, we're going to say SZ is the median to TY. The reason is if a segment connects the vertex to a midpoint, it is a median. Alright, that's it as far as our examples go. Next thing we're going to do is go through the answers from our work that we're going to have tomorrow. If you have questions at all on some of this stuff, we need to make sure we're bringing some good questions tomorrow. Okay, so here's our homework answers for 2, 4, 6, 8, 10, 11, and 12. Alright, let's do the best we can on this stuff. I'm not saying any of this stuff is easy. It's not easy. But it's something that I know we can all do. We're going to have to really work hard at some of this. Really think our way through. Probably more than ever. Because this stuff I'm asking you to do right now isn't easy. It's definitely things we can attain. Definitely things that we can do. And if you need a little help, let's make sure we're getting a little help. You got me after school. You got your FLC and your SLC. Let's make sure we're getting the help that we need. Have a good one.